and our electrical engineer.
Okay.
So I think they're a little bit more familiar, and Shannon probably is than Ann and I. So.
Okay. Okay. Excellent. Well, I'll run over kind of the anatomy of the systems, the basics on how it works, and then from there we can either have some specific questions. We could drill down into the software if you like. We've actually got a console hooked up to our network here at the office. So if we wanted to, we could have Jim go up and dial into that so we can see a live version of the software working on the screen if we want, and we can kind of step you guys through the basics of our setup and some of the functionality and different things that come with the system in terms of alarms or information that you might retrieve through CSV kind of sampling data and things like that. So if that's how does that sound good to you guys?
Yeah.
Fantastic. Okay, so the proposal that we sent you guys was outlining what we call is our STM12B Mercury sampler. We have two versions of this. The one we quoted you guys was this kind of smaller footprint wall-mounted kind of version. Now this is in comparison to something like this guy here, which is what we call our 6,000 unit. It's in a NEMA enclosure, a 20U, but for all intensive purposes, they're exactly the same unit. They have the same functionality. They do the exact same job. The reason that we developed the STM12B is we had some challenges with some of our clients in terms of getting equipment to the sampling location. As you guys are probably aware, often space is an issue, elevator space is an issue, all these types of things. So we developed the STM for those purposes, and we've had a lot of success with it. So that's the way we quoted you guys, but I just wanted to make you guys aware that we do have this NEMA enclosure 20U. It's a rack-mounted version, so you can see that the console here, the chiller, all of these are mounted basically like you would see on a SEMS rack, maybe in a trailer or a SEMS shelter. So they're easily accessible. They slide out, these types of things. Whereas you can see the STM there, it's kind of just being repackaged in a smaller version. So the chiller's a lot smaller. Instead of being rack-mounted, the faceplate here on the console actually swings out to give you access to all the internals if you need to do maintenance or anything like that. So that's a broad overview of the two options that we have. And again, I'll walk through how they work, but for all intensive purposes, they work in exactly the same way. So this is a shot of the actual unit on a stand. This stand ships with the unit. And it can be used as a permanent installation if you didn't want to mount the unit, say, on an annulus or wherever you might be putting this in the sample location. You can see that's a closest shot of the unit itself. We've got the touchscreen interface here. We also have the ability to access this with a laptop, things like that, but this would be a touchscreen interface running the software. This is our chiller unit here. We run a Stirling engine, which I can go to further in depth a little bit later. But that's our gas conditioner, our knockout for our moisture before we go to our dry gas meters for our volume reading, which is located up here in the console portion. We have our acid scrubbers here, which will kind of after our chiller has our moisture knockout, we run them through here. Kind of as a redundancy, it helps protect the dry gas meters and all the internal workings, knocking out maybe a little bit of moisture if it's left there, or some of those nasties that might be left in the sample gas that we can knock out. There's a combination of a couple of different things in here: carbon, Purafil, silica gel that periodically need to be changed out as they get used up and things like that. Our bottles here collect the moisture knockout that we have that need to be emptied periodically, and that can be done when you go up onto the stack to change out your traps. Right now, and I'm not sure how familiar you guys are with the reporting and the legislation, but part of the PS12B is needing to report stack gas moisture, say method 4 on a traditional US EPA method 4. There's several ways to do that. For 30B testing, which is the rudder or the basis of this legislation, we've petitioned the EPA to be able to do a gravimetric method 4 to be able to report the moisture in the stack using the knockout gas that you collect here in the bottles. We're in the process also of petitioning the EPA to be able to use that in PS12B, which is the constant sampling that you guys are looking at to be able to comply with the MATS regulations. So we don't have that yet, but we're hoping that we can do that. Some of our other competitors in the systems that they have peristaltic pumps which pump this moisture away. We've deliberately gone with this setup for several reasons. One is that we might be able to petition the EPA to do that gravimetric method 4, which would save you another step. It's already there. Why not use that information? And secondly, when you are pumping, we've got a closed system, so when you are pumping away that moisture with a peristaltic pump, you are losing some of your sample volume, up to 4 or 5%. And that can definitely bias some of your results, especially if you're running very close to limits and things like that. So you want to have a closed system to be able to make sure that the integrity of the data is coming out is as best that you can get. So this is an overview of the total system. So let me see if I can find, I'm going to skip around here, guys, a little bit. I apologize, but see if I can get you an overview of, here we go. So this is a shot of the front of the probe. So right here is the little glass tubes, which is our sorbent, which is our traps. And they look like, let me see if I got a shot of one. I'm not sure if I have a shot of one. Here we go. This would how a traditional PS12B trap would look. So you've got 3 beds of carbon, 1, 2, 3, with your gas inlet coming here and your gas outlet coming back down the probe. Your first bed here is used for your primary capture of your mercury. So as you're sucking your stack gas through the trap, you're collecting your mercury sample here on your first bed of carbon. The second bed of carbon is used as a QA/QC procedure for mercury breakthrough. So when we do the trap analysis, we're looking for any breakthrough that after the mercury is collected in the first, coming through to the second section, and it's got to be less than 5% of section 1 to be able to comply with PS12B on that breakthrough. Very rarely do we see any issues there, unless we have some really unique situations in terms of stack gas composition, moisture, things like that. And then finally, the third section of carbon is pre-spiked at the lab before the traps come out for you guys to use with a known amount of mercury. And then what we'll do is we'll do a spike recovery once we come back for analysis. And again, this is a QA/QC procedure to make sure that we haven't had any mercury loss or burning off of the mercury during the sampling time. So we can make sure that the integrity of what we're catching here is a true representation of what's in the stack. If we recover between 75 to 125% of the pre-spike level, then we're within compliance of PS12B. So that's the basic anatomy of a sorbent trap. So to go back to the probe face, you can see here we'll have paired sampling as per the performance specifications. We'll have an A and a B side. We'll go ahead and we'll slide these into the probe and slightly secure them here with some 10 millimeter nuts. And then what we'll go ahead and do is we'll go ahead and do a pre-leak check on the system before we go ahead and sample. And that's going to be as simple as putting a cap on the end of the sorbent traps here, hitting basically one button on your console on the software to say, go ahead and do a pre-leak check, and it'll run a vacuum. It'll pull sample and obviously pull a vacuum against the caps there that are on the end of the probe and make sure that we don't have any loss of anything through the whole system. So we're making sure we've got a nice secure system. Once we get the green light on that, we'll go ahead and remove those plugs on the end, and we'll go ahead and insert the probe into the stack. And then
quick question on the
sorry,
trap.
go ahead.
Yeah, a quick question on the traps. Now the trap design, that's laid out in the EPA specs, so pretty much any trap that's used to monitor mercury is going to be the same as any other trap in design.
It is. Now you will get variations depending on what you're doing. So a 30B trap, like a RADA trap, will only be a 2-bed trap. A PS12B will be a 3-bed trap. You might do longer traps for high acid or different things like that. Scrubber section. You might have a scrubber section, but the basic anatomy of the trap, yes, is sent out in specifications, and it's pretty standard.
Okay, thank you.
No problem. So once we go ahead and insert that into the stack, what we're going to be looking at then is basically pulling the sample through the probe. We will have a heater here in the probe, and it'll run down to about here, the first heater. And what that'll do is make sure we keep that sample above the dew point, so we're not getting any moisture in the sample, whether it be in the trap or coming down the probe, because that can affect our results. So we'll keep that sample nice and hot. We'll have what's called a probe heater, a secondary heater coming from this way for the back end of the probe. And the reason that we separate these two is the fact that if we, and especially where you guys are up in Michigan, if you're outside and you have part of that probe sticking out of the stack exposed to the elements, especially in winter, you might have a discrepancy between what the probe needs to heat on the back end and what it's seeing in the stack. So it just allows us then to maybe ramp up the heat, make sure that we're getting enough heat in the sections that we need it to keep that sample above the dew point and make sure that we're protecting the system from any moisture buildup. So the sample is going to come down the probe to our heated junction box where we make a union with our umbilical cord here. Our heated umbilical cord will bring the sample down, around, and join into the console box here, into the system. Then, and just keeping it real basic, what we're going to do is we're going to take the sample into our Stirling chiller here. We're going to make our moisture knockout, so we're going to chill that sample down and get it and remove the moisture out, which is going to, again, collect in these bottles. And then we're going to take the sample, we're going to run it through these acid scrubbers here on the way up to the console, which then, if I can get you guys a picture, I think I saw one before, and you can see the internal workings here of our console, has our dry gas meters. And again, you can see there's 2 dry gas meters for the paired sampling. So really what we're doing is we're sampling at the same time that we're kind of running 2 independent tests. So again, as per the regulation PS12B, we need to make a correlation between these 2 when we get to the end of our sampling to make sure they're within a certain % of each other to get a valid test. And then the sample is discarded into the atmosphere, and our meters continue to collect the information of how much volume that we're sampling. So that is a real rudimentary, introductory type idea of how a solvent trap system works. And again, based on the legislation and what's laid out in PS12B and 30B to be compliant with the MATS regulation. So can I answer any questions at this stage, kind of on the basics of how the system works?
I have a question. I think your sample rate is tied to your flow monitor. So what happens if your flow monitor is out of control?
I might pass that to Jim. And
if we just, and your flow monitor, is it coming in from a mod bus or a 4 to 20 signal?
I think it's a 4 to 20 signal.
Okay. Well, basically, if you drop the one, we'll alarm it for loss of signal, but we'll maintain the sample at the last known good rate that we receive.
Okay.
But we will pull up an alarm, and the alarm itself can be sent down to like your control center or your sim shack to actually fire off a bell, buzzer, or whatever you needed. Basically, it's a contact closure, but also on the console itself, it'll put on a red light. If you're logged into it, you'll see the screen be flashing that you have an error.
Okay. We have this thing at Ericsson sometimes when it starts up and during load changes where there's some swirling or something and the flow monitor pegs out and they have to play with the fans to get it to read well. We just had one of those incidents that lasted like 8 hours. So.
Oh, no.
So I don't want it to be tied to a number that's not accurate at all.
Now, we also can interface, and I don't know what your plant network and all looks like, but if you have a DAS system, you can actually use a Modbus interface and send the flow signal through that, which is a little more stable. It's a digital type signal versus an analog. But that also allows you to read all the real-time sampling data, temperatures, pressures, system stats, etc., back in your sim shack, and you can bring up alarms and things from that also. You can also remotely access the console from pretty much, if it's on it connects via an Ethernet connection, so if it's on a plant network or you have a VPN, you can get into your plant network, you can actually access the system from anywhere, depending on which depends what your IT security sets up and allows you to do.
We utilize the ESC DAS system.
Okay, yeah, that's what most people are using, and we're hooked up to hundreds of those around.
Okay. Now on this sampler, your sorbent trap is catching, and then you're also doing chemistry in the panel as well.
No, the kind of think of it. It's almost as a batch process. You set up your sampler to run for a week. At the end of that time, you would actually remove the traps and swap them out with a new set, and then those traps are actually, I don't know if you'll do the analysis yourself or you'll send them off to get analyzed to actually determine how much mercury is in the trap. That data is combined with the output data of the mercury sampler, and that's how you determine your concentrations.
So what is the chemistry happening in the cabinet?
Okay, in the cabinet, basically what the cabinet is doing is recording all of the volumes that are being collected, as well as all the temperature, barometric pressure, and then it also does all the control functions as far as maintaining a proportional sampling rate to your stack flow. So it's more of a control type thing versus an analytical box.
What do we run into if the carbon needs changed or the purifil needs changed? And it didn't get changed? How does that affect it?
Well, if the carbon didn't get full, usually what happens on traps, if you back up, normally you set them up to run a specific amount of time. Like I said, a week. At the end of the week, they have to change them. If you don't change them, what's going to happen? Eventually, they're going to start plugging up, and you'll get to a point where you're at a high vacuum and you cannot pull sample through them anymore.
Right.
Stuff like the purifil, if you don't change it or you don't empty your condensate bottles, you can back water up into the console, and that's kind of a serious thing that can happen.
So you're changing the carbon in the purifil at each trap change?
Not necessarily. Usually there's multiple sections in there. Sometimes and again, it's going to depend on what your stack is, how much moisture and things like that. A lot of times we'll see them where they'll change the silica, which is like the just the top half of the cartridge, more often than the carbon. The carbon will go for a month.
How do we draw a sample? Is it through a pump that's in the panel, or do we need to provide instrument air?
No, no instrument air is required. The actual pumps and all are in the console. You can't see it from this picture. But there's basically there's a manifold assembly that has the pumps, the mass flow sensors, the vac sensors, proportional valves, So all that's like one unit inside of there, but no, you don't need any plant air or any kind of an external pump. It's all self-sufficient, self-contained.
So basically all these acid scrubbers are doing is helping to purify the sample that you're drawing to protect your internal workings up here in the console, your dry gas meters, your tubing, things like that. So it's not actually affecting any of your reporting or things like that. It's merely just, again, helping to add longevity to the system as a whole.
Okay.
And then to speak kind of more on what Jim was talking about, basically, when you take your data, say if you do a 7-day run, you'll take your exported CSV, which will have all your run data from your console. You'll take your traps, you'll send them off for analysis, and basically at the end of the day, what you're going to get is a time-weighted average of what you collected on your sorbent traps to give you a concentration in your stack gas of how much mercury you have.
And once you know your concentrations multiplied by what your stack volume is, and that's basically how much mercury you're putting out.
Exactly. So kind of a lot of the reason that people go down this route compared to, say, a SEMS unit is, one, I mean, it's obviously much more cost effective. They're a lot cheaper, easier to run on a day-to-day basis. But they really are, for all intensive purposes, a plug-and-play unit that you hopefully, apart from any alarms that may sound or things like that from the source or high vacuum, things like that, you really only got to go and check them out maybe once a week. Go and change your traps, make sure everything's looking good, maybe periodically once a month change your acid scrubbers, do your pre-leak checks, stick the probe rack in, hit sample, come back again in a week. So they're really kind of autonomous. They run fairly well. We have about 350 of these running in the United States with great success. Obviously, we have those places where we may have high particulate, high moisture, but we do have answers for those too. So I don't know if what your stack composition looks like, or if you guys are concerned about any of those aspects at all.
When you open the panel, how does the cold winter weather affect your instrumentation? Does it have to sit and warm up before it can sample, or is it built to take right off?
It's built to take right off. You can see here, I mean, from a day-to-day running basis, we've got the AC unit built on the side, which will keep the enclosure.
Heat exchangers, heat and cold.
Right, it's heat and cold, so it'll keep it running in both summer and winter if we're exposed to the elements. Our Stirling cooler here, the reason why we kind of chose this design is for the fact that how well it can run in ambient temperatures. We can go right down into the minuses or right up into the 140s kind of with that Stirling engine itself. But again, that's going to be housed within our NEMA enclosure with our HVAC unit attached to kind of keep it at a constant temperature. And we've never had any issues with these. So really, the short time it's going to be exposed to the elements when you're up there once a week, changing traps, doing anything, will not affect the system at all. It'll go along like it's never been opened up.
Okay. What signals do we take out of the box that has to go back down to the DAS?
It's Ethernet.
Is that fiber Ethernet?
We come out with just RJ45, just Ethernet. If you put a fiber converter there, we plug right into that.
Okay.
So that Ethernet, I mean, if you're running an Ethernet down to the DAS, you'd use that same Ethernet to get your flow signal back.
That's correct. That's correct. And then that same fiber, one would connect, you basically connect it to the DAS, and the DAS will, send me my flow signal, because part of this, you actually have to run it in a proportional sampling mode, if you will. So as the stack flow changes, my sample rate has to change. So I need to constantly know what the flow signal is. But at the same time, you're sending me the flow signal, but when you send me the flow signal, you can actually pull all the registers. There's 140-something registers to give you all the real-time and ongoing data from the console as far as how it's performing, any alarms, status, how much time it's got left, etc.
So we provide power to it, and we provide an Ethernet, and that's all.
Correct.
The connection.
Power would be 220 amp, 110 circuits. We can offer this in a 220 also.
Okay.
And also from the Ethernet connection going down to the DAS, you can also from the remote location bring your laptop up and actually log into it without having to go up to the stack to check status in between during the middle of the run, if you will.
Do you have a convenience outlet to plug a laptop in?
Yes. Actually, I think it showed it. It might have showed in the picture that he had up there. Down in the bottom left corner, you can kind of see a quad outlet box down. No, outlet. 110
Yep, I
down.
see it.
Oh, down here.
Yeah, right there.
That's your, but there's your connections for your laptop.
Yeah, and what Nick's showing you, those right there, those are basically it's a front panel Ethernet connector. You could plug your laptop right in there. Of course, you are in this model. You actually have the touch screen, which you can do everything from there also. And then basically it doesn't show up, but coming out the bottom is where you actually have your Ethernet cable, if you will, coming out to go to your switch or your fiber converter.
On your umbilical cord, what's the outer jacket material?
It's called a pyro sleeving. We've used that for several years on our traditional Method 5 equipment. We've adapted it for here. So the reason we use it is pretty much because its durability and its exposure to heat. It can hold a constant temperature around about 300 degrees, but you could bang it up something upwards of 500-600, I think, on the pyro jacket.
Yeah, we don't run it that high.
We don't run it that high,
it
but it
can.
can.
250.
Yeah, we'll run it at 250, just above that dew point. But that outer sleeving is very durable, and it'll take any kind of things that'll bump up against it. And again, depending on where you're going to hold the unit as compared to your port sampling location, obviously we can make variations on the length of the U-cord from 10 feet up to 50 feet, 100 feet, depending on where you guys will be sampling. Now, just to confirm, all 4 installations are going to be installed. The console will be installed where you'll be doing the sampling. Are there any applications where you'd like to bring the sample down to a SEM shelter or anything like that?
That's kind of up in the air. We haven't decided. At Erickson, it'll be local. At Eckert, we have some options. We have the Sims trailer that will have plenty of space in.
Okay, the reason I just wanted to show after that is the fact that we have several configurations that we can do. So what we're currently talking about is this traditional configuration where we have the probe in the stack, we bring the U-cord over, we have the unit up there on the sampling location, and then again we have the communication down to DAS or anything like that. We have what's called our configuration 2, where what we'll do is we'll again have the probe and the U-cord up the top. We'll actually do the moisture knockout at the sampling location. Then we'll bring that dry sample down to a SEM shelter where we'll do our volume reading with our console down in the SEM shelter. And then a third configuration that we've had here is, again, probe umbilical to a heated junction box, and we'll take the entire sample down to a DAS where we'll do the moisture knockout and the gas readings all at the bottom. So we can configure these in any particular way that may be best if you have space constraints or anything that's unique to any particular one location that you guys are trying to sample with.
When you do configuration 2 or 3, is that dilution to get that sample down, or is that 100%?
100%, just a regular, permanently installed heated sample line is what we need.
The big difference between configuration 2 and 3 is that the permanent sample line going from the platform down to the SIM shelter Configuration 2, it just has to be a freeze protect line. Configuration 3, you're actually bringing all the signals, heater controls, etc., up through a heated sample line, which has to be kept up around the 250 mark. So.
What's the maximum distance?
Configuration 2 and 3, I've got them running 700 feet. I don't know if there's a specific maximum. You just have to design your permanent line, appropriate size tubing, and power connectors, etc.
For configuration 1, what's the maximum distance?
Well, the console, basically there's two pieces. One is the heated sample line going from the probe to the console there. 100 feet would be the maximum.
100, yeah.
Ethernet that's just basic. If you're running fiber, you go forever. Ethernet, you've got 100 meters. 100 meters before you have to start doing extenders or putting switches or routers in the loop.
Right.
This configuration 1 is pretty typical of most of the systems, more than half of what we put in.
Oh, yeah, definitely.
Especially if, and I don't know what your environment, especially if you have like an annulus, where you're semi-protected anyway, it's not so bad. Guys can get up there easy enough.
We've got that at one location.
Okay.
What's the weight of that probe?
The probe itself?
Yes.
40 pounds.
Yeah, it's under 40 pounds. One person can handle it. We normally put a monorail up. It just makes it easier for one person to handle the probe. It's basically they can leave it hang on the monorail. They just can slide it out, put the traps in, and slide it back in again. You can kind of see that in the top picture there.
Kind of up here, if you see.
Just makes it easier to handle, but it's not necessary.
No, it's not. But what we'll do is, if we do a monorail system, we'll do a J-hook on the front. So again, as you pull the probe out, you can rest the front of the probe on that J-hook and allow you to be hands-free to be able to change traps and do whatever you need to do.
I think at that elevation we've got about 7 feet in the annular space. How long is the probe?
It depends on your application, but a typical probe installation will be 6 foot.
You've got to extend a meter into the flow, right?
Exactly. So it all
Right.
depends on the thickness of walls and things like that.
And your port dimensions and all that kind of thing.
Exactly.
6 foot's our standard probe. We make custom lengths if we have to go to a 5 or something different.
Well, we could do whatever. I just made a 27-foot probe for a customer, so.
We don't want to do that.
No, we don't want that.
I wouldn't want to have to change that one.
No.
They're not excited about it either, I don't think, but they have to do. They're doing lead testing, which makes you sample within the centroidal area of the stack, so it's a specific length, and they just have to have that length to be able to get in there. So it's
At that elevation, the gas path is about 20-some feet across. The
Okay.
brick liner is 13 inches thick.
okay.
So we're probably going to be looking at probably a 10-foot probe to get far enough into the gas stream.
Possibly. Now, you said you've only got 7 feet.
Well, no, you said it's 8. You said the wall thickness is 18 inches.
13.
13, I believe.
2 feet there.
Yeah, because you only need to be a little over 3
3
feet into
yeah.
the stack for your regular sample.
So 6, maybe even a 7-footer, 6 or 7-footer, you'd get away with, it sounds like.
Okay.
Yeah, before we finalize things, I'd like, just if you can send me drawings or send them through Mick, and we can look at them and make sure, because, take into account for, the flange and the mounting hardware and all that kind of stuff, just to make sure we don't get up there and something doesn't fit, Do a site visit there.
Yeah, we can always do a site visit and make sure that we've got the right hardware for you as well.
Do you have any companies that are using it in the Michigan, Wisconsin, Minneapolis area?
I have quite a few, actually. One of them I've actually asked for a reference, but it was against company policy, allowed to go public. But they are up in your neck of the woods. We've actually got a couple going on up there that way. We've got several down this way. One I can tell you about is a company called Santee Cooper. I don't know if you're familiar with them down in the South Carolina area. We recently just did an installation 2 weeks ago for them. They put 8 systems in 2 locations. And again, we've got 350 nationwide that we've been doing over the last 7 years. And if you guys did want some references, I'd be happy to share that with you.
I would guess you probably got a lot down in Illinois.
A lot down the Ohio Valley, Illinois, as far out as Arizona. And then right up through Colorado. Yeah, Puerto Rico, we have some in there. And we're actually working with the European Union right now. They're developing some Mercury legislation based on 30B, and we're looking at doing some testing over there in Europe. They're looking to put some legislation into effect in 2016. Now, I'll leave it up to you guys. If we could look at some hardware here a little more, or if you wanted to actually look at a little bit more at the software, we'd be happy to share that with you as well.
Mick, what was the footprint of this? That 14 by 24, is that about correct?
That's correct, on the STM12B.
Okay.
Any more questions on the hardware or the unit itself, anything like that we can answer for you?
Oh, I'm good.
Go down.
Yeah, that's that J-hook I was talking about to allow you to hang the probe off the monorail system. And then you can see some shots there of the probes going into the. We have a cam lock and groove fitting here, so we can supply a flange with a packing gland that's attached to the probe. So what you can do is insert this into your stack and lock it down so it won't go anywhere.
So basically, when you're doing your trap changes, it doesn't take any tools. You just pop the cam lock and slide the probe out, change them, slide it back in.
Okay.
So the environment for the sampler or the pumps and whatnot, the NEMA 4, the enclosure, do we need any weather protection?
Nope, it's a standalone. It's ready to go itself. So
probably the guys working on it will need more weather protection than that does.
Absolutely, yeah.
Wind protection and just coverage.
Right. And I mean, we've had a lot of these units running for several years out there with really no issues in terms of environmental exposure.
For the one we put in the annular space, if the control box were to be mounted in the annular space, how would any leakage of combustion gas into that annular space affect the meter? If it's sucking air out of there that's got combustion gases.
The combustion gases as part of the sample are actually vented out of the cabinet after it goes through and is measured, and you can route that out to wherever you need to, window, whatever. As far as the actual gas in the annular space, the air conditioner itself it's like a closed loop system, so it's not actually drawing air in from the outside. It just recycles the air in the cabinet, keeps it from a constant exposure to that. If it did become an issue where it was real high or something, I have had people put air to the cabinet and just create a positive pressure.
I would think if we had issues with leakage, you wouldn't be able to send somebody in there to maintain it, so.
Correct. Yeah.
We
Yeah.
had that though at one point,
Okay.
where we had a brick or something fell down and damaged the duct, and it leaked into the annular space.
Okay. I mean, I've got a site that I was at back in January. They actually have to pressurize the annulus from down at the bottom just because the stack leaks so bad. They keep it pressurized all the time just so the guys can get up there and work. And, you know, it's one of those sites you got to carry gas masks with you all the time and that type of thing just in case the fans go off. So it's not the best environment, but we've been in there in that site 6 months or more now.
Okay.
There's like no rain cone or anything on it, it's open.
It overlaps like that, so you get airflow.
So you sell more of the configuration 1. Is that your recommendation? Because like I say, at Eckert, we've got an option. It's probably less expensive because you're not buying the long umbilical, right?
That is correct, because those umbilicals get expensive, you know, especially you start running a longer distance. And usually for the technicians, it's easier having it all up there together, so when they're changing their traps, they got the console there, and it just that needs to be more fun.
What would you guys see the challenges to be able to access this? Is it more weather-based, being up there in Michigan and not be able to get up the stack due to snow or things in winter? Is that a concern?
No, I think at Erickson we're putting this on the stack. Right?
Yeah, I mean, that's our biggest concern at Erickson is just accessing and you're going to have the access for the traps up there. So
Right.
I don't think having the
We have elevator access, but when the elevator's down, they got to climb the ladder, and they don't typically like that.
Yeah, I don't like that either.
Yeah, I worked out there for 10 years, and it was my worst nightmare. At Eckert, they're accessible from the roof and up a couple stairs, and it's easy access. So.
I think the biggest challenge there will be just getting the NEMA 4 in there the first time. You know, we'll probably have to pull some railing or something.
Yeah,
should be all right.
Sure, no problem. And really, the reason why some people might do configuration 3 is typically they might have all of their equipment in a SEM shelter and they kind of just want to go along with that same process. That's the only real reason we see that they may opt for the configuration 3. But I would say upwards of 80 to 85% of our installations are configuration 1. And you know, those times where you may have issues due to weather or things like that, we just recommended when you set up your sampling profiles, if you're aiming for a 7-day run, go ahead and set it at 10, just in the fact that you get a blizzard on day 7 and you guys can't access the unit, then at least you've got 3 more days that you can run with no problems and be able to get up there and change out your traps.
And even at that remotely, like I was talking about earlier, where you can actually remotely access the console from like the SenShack or somewhere on your network, you can actually go in and adjust your time and extend it if need be.
I know it was in the spec.
Okay.
Should I include it?
Did you include a monitoring plan and a QA/QC plan as part of the bid?
As part of the bid, typically not, because it's very site specific. We've worked with customers on that. The majority of our customers design something in-house for themselves, but we'd be happy to assist and share with you whatever information you need to put that together.
Okay.
I know it is part of the regulation, something you have to submit under PS 12B
Mm-hmm.
when you're setting that up.
What about the RADA? Is that part of the bid?
The router is, I believe, is not part of the bid, and I'm not sure what you're thinking in terms of, we have some clients who obviously bring in a third party to start with to be able to do the router on the systems, but then they buy our sort of condensed down version of this system, which is our 30B systems, to be able to do that going forward in-house. I'm not sure if you have a stack testing team or not.
No, we don't.
Okay. But we have a lot of clients up in your neck of the woods as well that are doing 30B testing right now with our equipment, and So we know some good stat testing companies doing that already.
What type of maintenance do you have on your probe junction box that you got shown there with the heater block?
I would say little to none as long as it's functioning.
Yeah, the only maintenance really required is, and what I recommend, when they pull it out, pull the probe out to change their traps, just use like a steel brush and knock any kind of particulate building off. But other than that, there's no reason to even go inside the that small box on the end is kind of like a junction box. There are keys on the back of the sample lines where you can actually, if for some reason a trap got stuck or broken, you can actually take off the back of that T and run a brush all the way down through the probe, to clean out any kind of blockage that you may have. But it's pretty much just kind of keeping it clean. Part of the software that handles, there's also what's known as a quarterly audit that's required to be done. That's all built in the software. It steps you through it, step by step, and it verifies that the barometer is correct and your TCs are correct and the volumes on the dry gas meters are correct. And that needs to be done quarterly as part of your QA, just for the method.
What consumables would we need to service the probe?
The probe itself, the only thing you need is on the where the traps go into the probe. There's some small glass-filled ferrules, and that's what actually makes the leak-tight seal. They need to be replaced, periodically, monthly, 2 months. And they're just, again, they're just small little 10-millimeter ferrules. You can't see it. It basically sits right behind that nut. Depending if you're required or not, there's a thing called a trap shield, which in high particulate areas right there, those are considered consumable, sacrificial, if you will. And as they wear out, burn up, depending again on your stack conditions, those would be considered a consumable.
Now, what condition would you use those in? Is that like a wet stack or?
A wet stack or a high particulate.
Okay.
The only other consumables you would have, that's it pretty much for the probe. The other consumables will be the actual, the scrubber cartridges. They need to be, recharged or the fill changed out periodically. But that's it for consumables other than, the traps themselves, which are part of your ongoing sampling.
Okay.
And then obviously, depending on your where you're going to approach your sort of risk of downtime, because I know you've got a limited number of hours per year that you're allowed to report to the EPA of downtime. We've had some customers do everything from keeping 1 or 2 sort of internal working electrical parts on the shelf that they might want to change out, everything through to I had one customer buy a complete 5th system that they're just going to have sitting in the closet that they can pull out at any one time and switch it out for a system that may be having some issues and get back up and sampling fairly quickly. So we kind of judge it on a per customer basis and how you would like to approach that. And we shared with you in the bid package some of those replacement parts or spare parts that we offer a lot of our customers.
Making the bid, you've got 4 laptops. Is that necessary?
It is not necessarily. If you guys have laptops in-house or you just wanted one to work across all 4 systems, whatever configuration you want to do, we can accommodate. The software itself, licensing-wise, is attached to the unit, not the laptop. So if you guys have in-house laptops that you want to do, we can definitely assist you in uploading the software and getting them up and running on in-house laptops to be able to communicate with them.
And there's no special requirements on the laptop. Any basic Windows 7, Windows 8 laptop will run fine.
Okay.
or even I have customers put it out on terminal servers. You know, it just depends on how you wanted to design your network.
Sure.
Now, speaking of that, do you guys have any interest of looking at any software? Do you want us to run through that at all a little bit, just showing you the interface and how things work?
Yeah.
Okay. I might actually pass the controls over to Jim, and he might actually will dial up this live working version, and you guys can just see how it. I don't know if you want the mouse there, mate, or not. There. You can close some of those windows if you need to, the PDFs or the PowerPoints. Is it that one or is it the
The one.
Okay.
Bear with me. I'm not on my computer. I'm on Mick. So. Well. I can't get it to launch.
No. I mean, I've got the PowerPoint there with some screenshots.
Yeah, I see that. Right. Sorry, I just little technical difficulty here trying to go across my network. It's like
I'm thinking about it.
I can't.
Can you open the PowerPoint there? Just to hit the PowerPoint icon. Just hit the icon and we can go back to recently opened. That's the software. Go to File. And then Recent, yeah. Recent, where you are. And then just open that product webinar at the top. Yeah, that'd be fine. If you go towards the back bottom. Okay.
Yeah, sorry, folks.
We're going to try and dial up the live unit that we had on the network, but for some reason I can't access it here. But what we do have are some screenshots we can walk you through real quick. Let me just see if this one might be more updated. Have some more updated. Okay, what's you?
Okay, so what I'm going to do is just kind of go through what this is what the screen looks like on the PC. So you kind of start out from your main screen. The whole idea of a test is considered a profile. Once you establish a profile, which says how long it's going to run, what kind of interface you're using for your flow signal, what alarms you want to set, etc. Once a profile is built, you can just keep reusing the profile. So you don't actually have to step through and recreate a test every time. Once the profile is built, if you kind of see on the right-hand side where it says test setup, pre-leak test, basically it's going to step you through one step at a time, keep you in sequence to make sure that you follow all the steps to actually get your run going. Okay, so here's the different screens. If you look down on the left-hand side, we got the main. Then that is the middle one. There is the core of setting up your alarms. You can see there's different ones. You set them for temperatures. You put in a range. Once you set an alarm, you can either have it just alarm it. You can actually pause the console.
Let me see if I got it closer.
The one on the bottom left corner, that's your actual test setup. I think you've got that on your next slide. No, you don't have enough. Okay. No, go back. Back one more. Okay. All right. So the bottom screen there, that's where you actually tell it what your sample rate is, what the external flow signal will be, what you want to set your heater temperatures to, how to handle external pause signals, and that's pretty much where everything is set up itself. On the other side of the screen is it's a shot of the leak check. We've got a better shot next one. That's what Mick was talking about. When you do your leak check, you cap your two traps. You hit start, and once it meets the criteria for the leak check and passes it, it'll change to passed. You accept it, and you're ready to go to the next step. Go down one more.
So with that leak test, if we were to have configuration 3, you'd have to have 2 people, or you'd have to plug the sample ports and walk to the SIMS trailer and do your leak test and then come back?
You would. And normally, I mean, typically you do your leak checks at the beginning of a run and at the end of the run. So someone's going to have to be up there changing traps anyway.
Sure. Yeah.
Right. So it's it turns into a 2-person job or a lot of up and down for a 1 person.
Okay.
Now, well, let me back that up. Not quite, because actually the person at the top of the stack, when they're up there changing their traps, they could have a laptop with them. If you had like an Ethernet port up there, they could actually plug into that. They could control the console that's down in the sim shack and actually still do his leak checks and start his test by himself.
Okay.
That makes sense? Kind of like doing a remote access to it.
Yep.
All right. Okay, so once you finish your leak check, you go to the next screen. This is what the actual run screen looks like when the console is running. You can notice you got, we talked a little bit about the adjust button down on the right-hand corner. That's where I can go in and actually change the time I want the test to run. I can also disable or bypass an alarm. If I have an alarm, I know what it is. It is just more, I'll call it a nuisance alarm. I could actually just turn off the alarm until the test is over, as a temporary one-shot. The screen itself displays what my flow rates are, what all my temperatures are, my barometric pressure, vacuums, valve positioning. The vacuum and valve positioner, we're talking about later when you start running longer runs. You start getting some buildup on your traps. Your vacuums will start to go up. Your pumps start opening more, and it'll get to a point where it can't sample any longer. And that's when you'd want to stop your test. If you set any alarms against any of these items, they'll actually be flashing red on the screen. Let's see. Yeah, that's pretty much it for that. Once you've completed your test, you go into your post-leak, which it looks identical to the pre-leak. The only difference is you actually run it at a little bit lower vacuum. Pass criteria is 4% of what your average sample rate was. So if you look at the top one, it's based on, or not the top one, but on your pre-leak, it's based on whatever you started your test at. The post-leak is based on what the average sample flow was for the entire test. So it could be higher or it could be lower. And basically, to pass the test, you have to be within 4% of that number. Okay. Next. All right, this is an example of what the output file looks like when the test is completed. It is we actually output, one is just a readable text file, the other one is a CSV file, which is shown here. You can see it has all the console information, software versions, dry gas meter IDs, trap IDs, all the temperatures, pressures, and it actually every minute creates a data record, so you can use it. That's more for maintenance to make sure the system's operating properly. The actual profile that you created to set up the test is down at the bottom of the data also. Okay.
The last screen.
Yeah. Then talk about the QA/QC. That's your leak checks. We talked about the 4% proportional sampling. These are all in the PS12 document under the QA/QC section. Calibration audit they're talking about at the bottom. That's the quarterly audit I was telling you about, which is built into the software. And once you do that, you do your annual errata, and that's pretty much it for the maintaining. I know that was kind of quick and high level. I'm sorry I couldn't actually get into the system to show you.
Sure, it didn't come up.
No, it would be on the bottom there. It's not there.
No, you're still thinking about it.
Yeah, I don't know. I'm not sure what's going on with your machine.
Sure either. Okay. So any questions or anything we can kind of go in depth more on the software?
Yeah, I don't think so at this point.
Okay. I mean, again, it's real simple, real intuitive. I know we've afforded you guys 2 days of on-site training, things like that. You'll be surprised after day one how fluently you can pretty much walk yourself through setting up a test and doing pre-leak checks and navigating your way through the software. It's really quite easy.
Okay. What is your lead time on 4 units?
For the STMs, I think right now I've got 2 in the shelf, so as long as they don't get caught up and sold by to someone else in the meantime, we'd probably be looking at about 6 weeks of having these delivered.
Okay. And ultimately, if you sell those 2 and you've got to build 4, we're still looking at 6 weeks, or?
It probably wouldn't change. We'd probably be looking at 6, maybe 8 weeks at the most, but we can knock them out in about 6 weeks.
Okay.
The reason we do that is we build them up from scratch. Then we'll do a minimum of 5, often a 10-day in-house run. So we have all the components of the system hooked up together. We'll actually let it sit there and run as if it was doing a test, just to make sure that everything's communicating right. We're not getting any alarms. Heaters are heating to the right temperatures, those types of things, just so we know that the system is complete and working when we send it out. So it's pretty much a plug-and-play application when you get it.
And
okay.
Installation is depending on how they're scattered out across the plant, et cetera, it's typically a day, half a day per unit.
Okay.
Just to get it in, and initial system checks and make sure everything's hooked up and connected to your DAS and all those kinds of things.
Sure.
And normally what we'll do is we'll come out and almost like I've just got like a 2-day. We'll spend first day assisting on the installation or getting the installation system set up, and then follow that with a training session. It's usually good to have the techs kind of there while we're installing, gives them a better feel and get a chance to talk to our technicians of things they've seen and how technicians like to talk about things.
Sure.
Just get familiar with it, and the what ifs and whys and those kind of questions come out pretty easy that way.
Okay. So you've got 2 days of setup, technical assistance. we've got 3 of these units going in at one plant and 1 going at another. They're just across town, so there's not a it's a 15-minute drive. That's doable, 4 units in the 2 days.
It would be, especially if you guys could have them at the sampling location before we arrive. That's kind of the thing that we find eats up most of the time. But if the units were sitting up on the stack,
Power's there.
You can chat, whatever is ready to go, we could pretty much knock out all 4 in 2 days.
Okay.
And
yeah, and we do have a rate I could share with you guys if you wanted me to formally quote it. If we wanted to add a 3rd day, obviously be at a much reduced rate since we're already on site. If we wanted to have that in our our back pocket in case you wanted a 3rd day for us to be there, either trading techs, do a different group of people on another site, anything like that.
Yeah, why don't you send Jacob that information?
Okay, I'll send that over. Now, I'm assuming, making the assumption again, that you have the 12-month extension, so you're looking at compliance of April 16, correct?
Correct.
Do you have any estimated kind of installation dates? I'm assuming it's probably going to be summer-ish for you guys up there rather than do it in the winter?
If we could, we'd like to have them up and running by the end of June.
Okay.
That's kind of our internal goal. We've got the ACI is in service at Erickson, but really no way to see how effective it is. So, yeah, that's what our internal goal is, to have everything up, running, functional by the end of June.
Okay, easily attainable from at least from our end in terms of getting equipment and getting you trained.
Jacob, you got reference contacts.
There were 3 of them supplied, yes.
Any
Santee, Mid-American, and East Kentucky.
Okay. Any other questions we can help with today?
Could you give me an installation list, and if you've got customers that don't want to share, you could just say confidential customer, but maybe in the states in our general area like Michigan, I'm assuming you have quite a few in Illinois because they've been having their program in place. And if you've got any up in Wisconsin, just so we can demonstrate to our people that, yeah, they're up here in the Midwest and functioning well. So.
Yeah, absolutely. I'd be happy to send that over. I'll send you a list of references, and if there's any confidentials, I'll be sure to.
Yeah, if they're confidential, just give us a list of units in the state,
in the area.
That's fine.
Not a problem at all. Happy to share that with you. And I'll send that through to you, Jacob, no problem.
Okay.
Okay, so I've got 2 things to get across to you today. Just trying to think from our end if we've missed anything we wanted to share with you, but I think we covered most everything.
Yeah.
Any questions that come up after, just if they're directed to me, you can send them through Mick, and he'll get them to me. Technical issues or technical questions that you may have.
Sure. Okay.
I let Mick does all the sales stuff, and I make them go.
All right.
Pretty much. Well, we appreciate the time that you guys dedicated to spend with us today, and hopefully we've answered everything that you were looking for. And again, as Jim said, if there's anything else we can clarify in terms of hardware, software, installation, configurations, or anything on the quote that we sent you, please feel free to reach out to me. We'd be happy to answer any questions you have.
We appreciate it.
You're welcome. And again, the offer's there. Jacob, I know we talked about setting this up first. If you guys regather and feel like you still want someone from Apex to come up and spend some time with you on site, we're more than happy to do that.
Okay. Well, thank you.
Hopefully it's getting warmer up there as well.
We're supposed to be, I think, 70 today.
No, rub it in.
We're getting into golf weather.
45, 50.
Wow. Yeah.
Around there.
North Carolina doesn't do too well with the cold weather.
That's shorts and t-shirt weather for us, though.
Yeah, excellent. Well, it was nice meeting everybody, at least if it was remotely. And again, we're here to help with any questions you have.
Thank you.
Thank you.
Thanks, everybody. Have a great day.
Sure.
Bye.
Take care.